Hello everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out the previous videos to follow along. In today's video, we will work on Subarray Sum Equals K. So the problem states that we are given an array of integers nums and another integer k. We need to return the total number of subarrays whose sum is equals to the given k. So for this, we need a counter variable initialized with 0 to count the number of subarrays having the given sum, and we need to consider all the possible subarrays and calculate their sum. If the sum is equals to k, then we would increment the count. So let's start iterating from I equal to 0 till the end of the array, and the second loop would start from j equals to 1 and we need a variable sum which is going to reset for every iteration. So we would be initializing it here, and we are going to add each number to the sum, and we are going to check if sum is equals to the given target k. If it is equal, then we would be incrementing the count, and at the end we would return the count. Let's run the code. It is accepted. So since we are using two loops here, this leads to a time complexity of O of n square. This works, but it is not inefficient for larger inputs. So if you observe closely, we are recomputing the sums each and every time for the overlapping subarrays. So instead of recalculating these sums, we would store into a prefix sum, and we would track how many times we have seen a particular sum before. So this hints towards using a hash map. So the optimized approach for this would be a combination of prefix sum and hash map. For that, we need a map and the base condition would be, we'll be putting 0, 1, and we need prefix sum variable which is 0, and we also need count to count the number of subarrays having the sum. And now we are going to iterate. We don't need any index, so we would be using for each loop, and for each num in nums we would be adding each number to the prefix sum plus equals to num. Now we would be checking if its complement is present in the map. Complement is nothing but prefix sum minus the target. If it is present, then we would be adding it to the counter. If it is not present, then we would be adding it to the map. Sum and it is already present, we will be incrementing it to 1, otherwise we default it to 0. And at the end we would return count. So since we are doing it in a single pass, the time complexity would be O of n and the space complexity would also be O of n, because we are using extra space in the form of hash map. So here, let's run the code first. Let's submit it. Okay, it is accepted. So now we need to see why this works. The hash map stores how many times a prefix sum has appeared. If prefix sum minus k exists, it means that the subarray between those two indices sum is equals to k. This also handles negative numbers, and the edge cases are, this works with negative numbers, it handles multiple subarrays with the same sum, and the base case map.put of 0, 1 ensures the subarrays are starting at index 0 are counted. Now we need to know when we should use this pattern. So we need to use prefix sum plus hash map when you are counting subarrays, when the elements can be negative, and when the order matters. So this problem is a classic example of how we move from brute force to optimized approach by storing the repeated work using some extra space. That is it for today's problem. In the next video, we will continue with the next problem, removing duplicates from sorted arrays. Thanks for watching.